Let's go ahead and look at this situation. So, guys, is this in factored form or expanded form? Of course it's factored form, because you have this times this, two factors, right? Because that's what a factor is. So this is in factored form. Also, the instructions say to expand it, so that should have been a hint. So let's expand this, please. How do I expand a binomial trinomial? It's just like FOIL, except you've got to do it 3 times, right? So if you're bad at FOIL, you're going to want to write this out. Now, if you've been in my class in the past, I've given you a way to write this that makes it tidier and easier to work with. I plan to write it out that way. So I deal with the first term. Y cubed plus 2y squared plus 4y, yes? And then I deal with the second term. Now, because it's a new term, I'm going to write it on a new line. 2 times y squared is negative 2y squareds. And I put the y squareds together. The next one is negative 4y. And I put the y's together. And then minus 8. And I put the constant with the other constant. Since there isn't another constant, it makes that. Then all my like terms are already lined up. So all I do is add them. Y cubed. What is 2 minus 2? Gone. What is 4 minus 4? Gone. What's 0 minus 8? Negative 8. And that is my final answer. All right. Now, come over here and do the same thing. X cubed minus 3x squared plus 20 plus 9x and plus 3x squared minus 9x plus 27. And that gets me what when I hook it up? X cubed plus 27. Right? Everybody's with me? Now, please look at the title of today's questions. Factoring a sum, or a difference of cubes. Is y cubed cubed? Has that got a cube root? What is it? Y. Does 8 have a cube root? What is it? 2. Excellent. X cubed, x, 27, 3. Now you guys, this should tell you something, right? Because if it happens once in math, how often does it happen? Every time. So is this one was a difference of cubes, yes? And you will notice that y cubed has a cube root of y, yes? And 8 has a cube root of 2, yes? And minus. Everybody cool? What about this one? X's cubed root, x cubed root is x, 27's cubed root is 3. And since it's plus, this one's plus. Everybody cool? And the only other change is where? Plus or minus. Everybody good? So what does this mean for us? This is what it means. If I have any 2 cubes, ever, I can factor it the following way. If it's plus, I'm going to work in red. All right? If it's plus, then my signs out here are plus. What's this one going to be? minus, what's this one going to be? Plus. If my sign out here is negative, which I will circle in blue as soon as my computer thaws, then it is minus, and what goes here? Plus and plus. Now please notice, it is simply, this x is simply the cube root from here. And this y is the cubed root from here. Everybody got it? And then these are common sense, aren't they? Right? 3x, x and y, 3 and x. Y squared, 3 squared. So let's try this with the very first one. If you're bad at distribution and you're having trouble with factoring, then most of the time you can at least in factoring fall back on the steps, right? So if you're bad at figuring this out, you do have this thing. So is this our x or our y according to our formula? It's our x because it's the first one, right? Okay, even though this actually says x, if you don't know what you're doing and you have to follow this formula, then you have to recognize that that is the first term, yes? And that is the second term, right? So if I was going to factor this, it's negative, so I'm following the blue line, aren't I? If I follow the blue line, it's the cubed root of the first one. What's the cubed root of 1? 1. Follow the blue line minus, what is the cubed root of the second one? X. So 1 minus... there it is. 1 minus x. Is everybody good? Okay. Now this one is our first term squared. Well, what's 1 squared? 1 plus the first term times the second term. What's the first term? 1. What's the second term? So how do I write that? Do I write 1x? No, I just write x. And then it's the second term squared. Second term here is x, so I square it. Is everybody cool? Everyone's good? Because these easy ones just follow the pattern. Is everyone good? All right, let's look at this one. Can I do this one? Is it going to follow the red line or the blue line? The red line. How do you know? Because it's a sum of cubes, right? So let's go ahead and do that. It's going to be the cube root of that. What is it? What's the cubed root of that? X. Plus, what's the cube root of that? 8 in brackets, then x squared, right? X squared minus x times y. 8x, lovely. 8x, x times y, plus, which is 64. Can everybody do this? Okay. Try C. It's exactly the same as A and B. You try it. I'll wait a moment. Then I'll fill it out. Got it, Jeffrey? Nice. I'm going to a concert this weekend, Sarav. Imagine Dragons. You know who they are? Uh-huh. Always make fun of the bands I go see. You know there were 8,000 people at that show, right? There were. Huh? Well, it was very difficult to get tickets, and it's in GM Place, so probably around 17,000. They were a little bit bigger than the Arkells, yes. The Arkells are awesome. All right, so what is my X and Y here? 1 minus what? This is where it gets a little tricky. Pardon? 10D. Was everybody able to get the first part? Does everybody know why? Because that is the cube root of 1 and the cube root of 1000D cubed. Everybody cool? Everybody's good? All right. Since it's negative, I'm following the blue line, yes? All right. So the first one is, this is my X, yes? And this is my Y. So the first one is that squared. What's that squared? 1 plus XY. What's that? What is X times Y? Plus 10D. Excellent. And the last one is Y plus Y squared. What is Y squared? 100 D squared. Is everybody cool there? Going once. Going twice. Going thrice. Excellent. Now, is D different in concept or method? Or is it only different in looks? It's different in looks. Is this a cube root? Or a cube, I mean. Yes. Is this a cube? So can we do these? Sure we can. I take the cube root of the first one. What's the cubed root of 27y cubed? 3y. Minus, so what sign goes here? Minus, what is the cube root of 125? 5. Now, does that give me my X and Y to follow the formula? Yes. Even though this says Y, if we're following the formula, it's the first term, so it's the X term. Agreed? Okay. So, what is that one squared? He waited patiently. 9. Y squared. Since it's minus, it's plus. What's this one? It would absolutely be 15y because it's X times Y. Plus 25. Nice work, Barker. Can everybody do A, B, C, and D? Okay, now stop for a moment. Do not lie to yourself. Do not lie to me. Do not sit here and say, I got this, because you've been copying down the answers between talking to the person beside you. Look at this right now. Honestly assess if you see how this distribution and then factoring works. Does everybody see it? At the very least, can you follow this pattern? Yes? If you can't, can I read your mind? No, because that would be the worst superpower ever. So, since I can't read your mind, you have to tell me where you're messed up. You have to tell me, because I don't know where you're messed up. Do you recognize that the first term, the first factor, is simply the cube root of over here? Do you get that? Yes, Luke.
When you use the positive and negative,
The reds and blues? Okay. If it's positive, then it's plus, minus, plus. If it's negative, it's minus, plus, plus.
So for like the 27y3 minus.
Yep. So since that started with a negative, they're both going to be positive in here. Every time. Cool? If that was a positive, it would be one of each. Got it? Good question. Anybody else? Okay. Now, let's look at 6. Does 6 mess with our mind a little? Why? 7 is not a cube root. But we think back to the very first day of factoring in grade 10. And what did Mr. Myers or Mr. Keeley or Mr. Abraham or Mr. Fujimura or Mr. Hirschman, what was that? What was the first kind of factoring that you were taught way back in grade 10 by one of those 5 people? GCF. Is there a GCF here? What is it? 7. So what is my first job? Divide by 7. And how do I write that? 7 x to the 6th plus 1. Is everybody cool there? Yes? Okay, now, you should notice, since we've already done exponents, does this have a cubed root? So what I am asking you is there a cubed root of x to the 6th? Yes or no? Yes, there is. What is it? X squared. Does everybody remember why? Because I'm looking for groups of 3 and I can take out 2 groups of 3 there, yes? So I can get a cube root there, can't I? Does 1 have a cube root? It is 1. So this is a sum of cubes, isn't it? So if it's a sum of cubes, will it work through the formula? It will, won't it? So we're starting with 7, and then I need the cubed root of this first term, because this first term is my x, that 1 is my y. What is the cube root here? X squared. Everyone agree? And since that's plus, it's plus. And what's the cube root of 1? 1. There's my x and y, isn't it? So now, all we do is work through it. This first term is supposed to be x squared, yes? Well, my first term here is already x squared, so I got to square that, don't I? So what is it? X to the 4th. Awesome. Luke, since this is plus, what's going here? Subtraction or addition? Subtraction. Nice work. Then I put these two together. What is 1 times x squared? X squared. Awesome, possum. And the last one is this term, squared. What's 1 squared? 1, and it's plus 1. Is everybody cool with that? Yes? Yeah? Okay. Let's look at F. is F exactly the same thing? What makes F look weird? It's got 2 there, doesn't it? If I had just that, could you do it in your sleep? Yeah. If I had just that, could you do it in your sleep? Yeah, because it would just follow the formula, right? So when I have both of them, it's still the same thing, isn't it? Does this have a cube root? Of course it does, because I can take out one group of 3x and one group of 3y's. So this has a cube root. Does this? What is it? So that means I can do this, can't I? The cube root of the first one is xy, as Sukhpal says. Plus, what's the cube root of 64? 4. There is my x and my y to run it through the formula now, yes? First term is x. The first spot in the formula is supposed to be x squared. So how do I square that? It would be x squared y squared. The next term in the formula, since this is add, must be a subtraction. And it's x times y. How do I multiply those two? 4xy. Look at you guys. It's like you're good at math. And the last one is 16, plus or minus 16. Holy crap. Everybody good? Yeah? It's not that hard, is it? You just got to remember, cube root, square together, square. Right? Okay. Now, listen please. You already hopefully have done a little bit of work on 57. Hopefully. If you haven't, it's no big deal. As I said, I'm going to let this sit here for a moment while it's recording so you can check your work tonight. All right? It's recording. It's been recording for 20 seconds. You can pause on this page and check your work tonight. Good? And tomorrow, of course, I'll ask if anybody needs to go over any of it. I can't remember where I stopped. So 10 to 16 or 9 to 16. Yeah. So that's been up there long enough, right? You'll be able to check. And then there is up to 20. That's where I asked you to go, right? I also said you could go a little further if you wanted to. Okay? Now, listen to me closely, please. From 21 to 30, it's all difference of cubes, or sum of cubes. So now you can finish up to the end of page 60. Okay? That's your job. Tomorrow in class, we're going to do 61. And you will notice that page 61 is an assignment. This is your review for your factoring test. Everybody cool? Since it's an assignment, it's going to be marked. It's going to go on check my mark. Yes? So if you haven't been doing your due diligence and marking your own work and asking me for help if you need it, then come Friday, tomorrow, you're not going to be in very good shape, are you? Okay? In a perfect world, tomorrow, 80 minutes, we would get all of page 61 and 62 done and marked. In a perfect world. Very rarely are we in a perfect world. Most likely, I imagine 62 is going to have to go home with you over the weekend. I actually wouldn't mind if that would be the case, because then, you don't have a 3-day gap between ever practicing this. All right? I'm not going to give you your tests on the first day back after a long weekend. You're not going to get your test on Tuesday. Most likely we'll be marking this on Tuesday. Okay? And we'll be testing most likely on Wednesday. I know that's first block again, but it's 4-day week. I'm screwed over by it. I don't want to give you the factoring test on Thursday because Thursday is short day, only an hour class, right? And I don't want you to have to stay into your lunch. Understand? So we'll still probably do this test on Wednesday, first block. And I'm not too worried about it because really the only new thing we did is today, right? Other than today, it's all factoring that you already knew how to do. So I'm not too worried, and nor should you be. Everybody cool? All right, now, before I let you go, some of you are probably comfortable and ready to start, yes? Some of you would probably like to see one or two more. If you want to see one or two more, then just keep your eye on the screen, and we'll do a couple of questions from the first page that I assigned you, which was 58, number 21. Okay? If you need to see another couple, I'm going to work through a couple right now. All right? While I'm recording. If you're ready to go on by yourself, go on by yourself. If you're somewhere in the middle, try this by yourself and then just come back and check if you've done it right. Everybody cool? Okay. Now, what I would like to do though is just work on this and not talk. Because if there's people that are working and I'm speaking, that's going to interrupt with their thought processes, yes? So I'm going to just work this very slowly, showing you everything that I do, right? I'm going to do nothing in my head. Everybody cool? All right, so I'm going to work on, I'm probably going to do the first 4 here. That should be enough for everybody, yeah? Okay. Nice. Everyone's good with that? Yeah? course. Okay. I didn't notice a lot of people watching, so I'm pretty confident that most of you have this down. Okay. Can everybody follow me here? Okay. Do you want me to leave the screen up while I fill out the rest of the key that's going to end up being on the video? So if you are working on one, you can maybe come and check, make sure you're still on the same. Is everybody cool with that? Okay, again, I need to know I can walk around and help you, or I can finish this and you'll have it tonight to check on your own. My number one complaint I've been getting this year from all levels is I remember how to do it in class, but I forget how to do it when I get home. Right? Which means if I walk around and help now, that's less than I can show you when you get home. But if I fill out more of this slowly like I'm doing, was this a good pace for people? With all the highlighting, that helped?
Yeah.
If I keep doing that, then you'll have 20 to check against later tonight. Okay, now I know some of you would like me to walk around, so what I'm going to try and do is finish this quickly, but showing as much work as I can, and then I will still have some time to walk around. I'm going to try to get the best of both worlds. Is that going to work for everybody? All right, so right now continue is everyone's thing, right? Okay. Now, ladies and gentlemen, if you don't have your cube roots memorized, then you've got to check if these are perfect cubes, right? Like you'll notice I'm not checking any of these because I know the perfect cubes up to 10, up to 1,000, okay? But that's only because I practiced so much. You may need to check with your calculator if these are cube roots. Cool? Okay. Should I continue on right now to page 60 with all the key? Or are people feeling that they'd like some walk around time? Keep going with the key? Yeah? Okay. The first part of 59 is old stuff anyway. Don't know, man. When the bell goes.
6 minutes.
There you go. I've never understood why you guys care that much. Mm-hmm.
Can I go?
Of course.
Okay, thank you.
Bye, guys. Bye, guys.
I'm supposed to go with my physics class, but I'm not sure about the chemistry teacher. I have to ask the chemistry teacher if it's okay.
Bye. Hey, Justin.
Hello.
test tomorrow at lunch.
Tomorrow what?
At lunch.
Yep.
Yeah, okay, I'll do it.
Hello, Mr. Mars.
Hello.
I need some help real quick with some trigonometry.
Mm-hmm.